In this lab, we will do data visualization with common graph types. This notebook introduces common types of graphs using common data visualization packages in Python, Matplotlib, Seaborn, and Plotly. Let's first import these packages. So for data visualization, we need to import matplotlib.pyplot, and we let it be plt. So import matplotlib.pyplot as plt. We also need pandas and numpy. So import pandas as pd, import numpy as np. Then first we show evolution in the data using line chart. Line chart is often used to show a trend in time or other units. The most common line chart has two dimensions. Example, time on the x-axis and value of something on the y-axis. Let's make an example here with the COVID-19 dataset. Let's first download the data. So let confirmed df equal pandas, which is pd dot read underscore csv, and the web address. So this is the web address from where we will get the data. Then confirm df, let's look at the head part of it, the first few lines. So confirm df dot head open and close bracket gives us this. So where we have columns province, country or region, latitude, longitude, and the dates on which the data is taken. And then we fill it up with the data information. Confirm df tail dot tail open and close bracket gives us the last few lines of the confirmed df data frame. Then we print confirmed df of country or region. So this is how it looks like. And if I do unique, then that gives the different countries or regions. For country in confirmed df, country or region print. So this prints one country per line. Afghanistan, Albania, Algeria, Andorra, so many countries. So there are about how many? So if I do length here, this will give me the number of countries. There's 201 different countries. Then let df nz equal confirmed df of confirmed df country region equal New Zealand. So we are subsetting the data frame where the country or region is New Zealand, and that gives the 3 rows. And if I do dfnz dot index location 1, that will give me so the first row is index location 0, the second row is index location 1, and the third row is index location 2. So I want to pull out the index location 2 of province or state Niue and country or region New Zealand. latitude minus 19.0544, longitude is minus 169.8672, and that gives that. So we let it equal to df and z. Now if I do df and z dot index location square bracket 4 and then the colon, so that will print. So the first row is index location 0, second is 1, third is 2, fourth is 3, index location 3. The fourth row is for index location 3, and the fifth row is for index location 4. So df dot nz dot I location for square bracket 4 and then the colon will give me all the data from 1/22/20 and onwards. So this is how it looks like. So we have already imported matplotlib.pyplot, so we don't need to import that again. So if we plot a plt.plot of dfnz square bracket 4 and onwards, and then plt.xlabel bracket date, plt.ylabel number of confirmed cases, and the plt.xsticks of np.irange from 1 to dfnz.shape 0, and in the space of 90, that will give us this. So what happens that, let's show this separately. Okay. So plt.plot, this will show us the graph like this. So there is no x label, there is no y label. So let's label the x-axis and the y-axis. So x label, let it be date, and y label, let it be number of confirmed cases. So it takes a bit of time here. So we can see that the x-axis is now labeled date and the y-axis is now labeled the number of confirmed cases. so this will give us the X level and the Y level like this. And then see, okay, so the X sticks are very hard to see, so let's change that as well. So we'll do plt.xsticks open bracket np.irange from 1 to df New Zealand dot shape 0, 90. So if I just insert a cell to show you the irange part. Okay, so a DF in New Zealand looks like this, and then the shape of it is the number of rows is 1147, and if I put 0 in the square bracket, then that will give us just the number of rows. Now if I do NP, if I NP arrange 1 to the number of rows, that is 1147, that gives us the values from 1 to 1146. And if I put 90, 90, this will add the space. So after 1, the next value will be 91, and the next value after that will be 181. So let's have a look at that. Yes, so you can see the distance is the values are at a distance of 90. So plt.xsticks np arrange 1 to df New Zealand dot shape 0, that will give us the number of rows, which is 1147, and comma 90 at a distance of 90. Let's run that. So these values are at a distance of, the xstick values are at a distance of 90. This is a good but has too many warnings. If you are also annoyed with them, we can turn them off by putting a semicolon next to PLT xsticks. We also rotate the xsticks by 45 degrees to read the dates better. So if I don't put this semicolon, we will get some warning message. See this? So if I put the semicolon, then we won't get this warning message. So you can see, we can see that the xstick values are overlapping. So to avoid the overlapping, we put the xstick labels in the 45-degree angle. So to do that, we will do plt dot x ticks bracket rotation equal 45. So this is how it looks like. And if I put hi equal right, let's see what it gives. So horizontal axis, so it starts from right. So at the moment it looks like that. You can see the face tick value is not very aligned with the label. So let's see if this improves our labeling of the X tick values. So that improves better because we can now see that it is better aligned. So, and the X label is labeled as days from 22/1/2020. So now let's plot another country to this plot for comparison. Let's compare this plot with Australia. So DF/AUS equal confirmed DF, and then we subset the country or region equal Australia by passing confirmed DF square bracket country or region equal Australia. And it looks like this. The province or state is of Australia, the country or region is of Australia, and the latitude, longitude. So there are 8 rows of data. There are several states in Australia. So let's just take Victoria as an example. So we can see that Victoria is in row number 2, 3, 4, 5, 6, 7. Row number 7, but the index location will be 1 less than that, which will be 6, because the index location starts from 0. So let DF/AUS equal DF/AUS dot index location square bracket 6 comma and so on. So that will select all the values in that index location, and that prints this. Province or state is Victoria. Now let's plot this. Now we can see the data starts from which row? 1, 2, 3, 4, 5. Row 5. Row 5. So index location is 4, because the index location starts from 0. So yeah, it should be 4. Okay, so we can see, okay, plt.plot df and z 3 and so 3 from 3 row 3 and index location 3 and so on. That will be the longitude. We don't want that, so we want 4 here. Let's run that and we will show the error. Yeah, so we want 4 here because the data starts from 4th row. So let's correct that. Let's put 4, and same for the DF/AUS. It starts from 4th index location. Label equal Vic. PLT.X label days from 22/1/2020. PLT.Y label is number of confirmed cases, and we want PLT.X ticks from NP.A range from 1 to the number of rows, and then the number of rows is DF and Z df nz dot shape and then square bracket 0 and comma 90. 90 is the x ticks are at a distance of 90. plt dot x ticks bracket rotation equal 45. And then we want the legend as well. So plt dot legend open and close bracket. And when we run this, that will give us this. As you can see, to plot more lines to the figure, we can simply add another plt dot plot. So use the same method, compare New Zealand with 3 other countries of your choice. For more options to plot with Matplotlib, okay, so we will okay. So confirm DF. Let's see confirm DF. So confirm DF looks like this. Display confirm DF country region dot unique, that will display all the countries. And let DFFJ equal the subset of the data frame, but where the country or region is Fiji. So DFFJ equal confirm DF square bracket confirm DF square bracket country or region equal Fiji. So that gives us one row, as you can see. And let DFFJ equal DFFJ dot index location square bracket 0 comma onwards. So that gives us this. And let DFTG equal confirm DF square bracket confirm DF square bracket country or region equal Tonga. So DF underscore TG gives us one row. And let DFTG equal DFTG dot index location square bracket 0. So index location is 0. Let DFSAM equal confirm DF of square bracket confirm DF square bracket country or region equal Samoa. So printing DF underscore SAM, that prints the one row. Let DFSAM equal DFSAM dot index location square bracket 0 and onwards. So we want there is only one row and the index location is 0. Compare plot with 3 other countries. So plt.plot, so DFNZ from the index location 4. So because 0, 1, 2, 3, 4 index location, the data starts from 4th row. And label equal NZ, Australia from the 4th row. Label equal Victoria. plt.plot DFFJ from the 4th row. Label equal FJ. plt.plot DFTG for the 4th row and one index location 4 and so on. Label equal TG. plt.plot DFSAM, so 4th row and onwards. Label equal Samoa. plt.xlabel days from 22/1/2020. plt.ylabel number of confirmed cases. plt.xticks np.arange from 1 to the number of rows. dfnz.shape square bracket 0 at a distance of 90. plt.xticks rotation equal 45. plt.legend. So we want the legend as well. So we get this. So we can see that all the graphs they follow the similar line along very close to 0. So it's almost 0. And then it starts rising for Victoria, Australia. The number of cases start rising. So the first one whole number, one person, is on 14th of October, 2021, and then it starts rising. So you can see that there is close to 3 cases. These are the confirmed cases on the 7th of January 2023. We can see there is 3 cases. But the green line, which is for Fiji, is very close to 0 now for the number of confirmed cases. And for the rest of the places, New Zealand, Tonga and Samoa, is very low. It's almost a straight line along 0.